So here it is, Unit 1, Lesson 5, Solving Linear Systems by Graphing by Hand. So we're going to look at some equations, some linear systems, and we're going to graph these equations and solve these systems by looking at the point of intersection. So let's look at the first one. So here we have y equals 1 over 2x minus 5 and y equals negative 2x. So we're going to graph these two equations. So the first one is 1 over 2x minus 5. We're going to need a y-intercept of negative 5. And we are going to do a rise over run of 1 rise and a run of 2. So my next point would be right here. And a rise of 1 and a run of 2. My next point would be over here. And so on and so on. It's a positive slope, so it's going to go increasing. And then we're going to create a line connecting those points. And here it is. I'm just going to extend the line further and further and further, just so that we can capture as many of these points as possible. And right there. Okay. And then the next equation is y equals negative 2x. So this has no y-intercept or y-intercept of 0. So we're going to start at the origin, and the slope is negative, so we're going to go down 2 units. So the rise is negative 2, so down 2 over 1. So there's my next point, down 2 over 1. And there's my point. And as you can see, as I plot the line for this equation, all right, here we go. For some reason, it's trying to snap. Okay, and fix the other end. There we go. Okay, so there's my line, and then you can see clearly the 2 points, or sorry, the 2 lines intersect at one point right here at positive 2 for x and negative 4 for y. So we're going to say here the solution is positive 2, negative 4 as a coordinate pair. Okay, so that's how you do it. If you still need a refresh on how to graph lines, I suggest you look at my previous video. Example number 2. So here's another set of equations. X minus y equals negative 1. So for that, I need to kind of convert this. So to convert to y equals mx plus b, so it helps me graph it. And the other equation is 2x minus y equals 2. So the same thing. Convert to y equals mx plus b form. And graph. That's basically what we are going to do. So for the first one, x minus y equals negative 1. Well, if I subtract x from both sides of the equation, I would have negative y on the left remaining and negative 1 minus x. Now I don't like that negative y, so I'm going to divide everything by negative 1. And so that will give me y, positive y. Negative 1 divided by 1 is positive 1. Negative x divided by negative 1 is positive x, so 1 plus x. Okay? Or you could say y equals x plus 1. Now, just by commuting the x and the 1. The other equation, 2x minus y equals 2, I have to do something very similar to that as well. So I can subtract both sides by 2x. So on the left side, I'm left with minus y. On the other side, on the right side, I'll have 2 and my minus 2x, because I subtracted both sides by 2x to keep the equation balanced. And then I need the positive y again, so divide everything by negative 1. So if I divide this by negative 1, divide this by negative 1, divide by this by negative 1 to keep the equation balanced. That's what we're doing. So on the left side, I have my positive y. And then on the right side, I'll do the x first. Negative 2x divided by negative 1 is positive 2x. And 2 divided by negative 1 is minus 2. Okay, so there you go. There are my two equations. I'm going to graph them now, starting with the first one here. So y equals x plus 1. This is simply, well, 1 is my y-intercept, and my slope is positive 1. So I'm just increasing my line like that. And then I'm going to connect those points with a straight line. Okay. Let's see here. It's not quite lining up nice. Let's fix that a little bit. Okay. Yeah, basically going to shake the screen a little bit until you get it right. Okay, so there's my first line. Let's look at the next one. Y equals 2x minus 2. So I'm going to need to, these are different color here. So let's say minus 2 is my y-intercept, and positive 2 is my slope. So up 2 and over 1, up 2 and over 1, up 2 and over 1, and so on. Okay, and let's connect those points with a line. Something like that. I'll fix it over here like that. Now, even without the line, you can, those points themselves already indicate that here we have a point of intersection. So my point of intersection, or the solution, is here positive 3, and for the x value, and positive 4 for the y value. Okay, example number 3. Let's look at this one. X plus 2y equals 4. So let's say that's my first equation. 2x plus 4y equals 8. That's my second equation. Sometimes it's good to label which equation is which by numbers, so that you know what you're working with. So it turns out, if you look carefully enough, well, let's see. Let's look. Well, even without looking carefully, let's just do some manipulation here. So what if I took the first equation and isolated for y, right? So basically here, x plus 2y equals 4. And if I divide everything by 2, I would get, so if I divide this by 2, I'd divide this by 2, divide this by 2 to keep the equation balanced. What would I get? Well, 2 divided by 2 cancels out. I get y by itself. 4 divided by 2 is 2. And then x over 2, if I bring that over to the other side, I'd have minus 1 over 2x. Okay, that's fine. Let's look at the second equation. The second equation says 2x plus 4y equals 8. What happens if I divide this equation by 4? And the reason why I'm doing it by 4 is so that I can get the y isolated. So 4 divided by 4, 4y divided by 4 is just y. On the right side, I have 8 divided by 4, which is 2. And 2 over 4 simplifies to 1 over 2. And if I bring it over to the other side, I get minus 1 over 2x. And so it turns out that these two equations are equivalent. Okay, so we're going to say here, these equations are equivalent. What does it mean when they're equivalent? It means that they are the same. They are the same equation. They represent the same line. So what does that mean? Well, two lines that are overlapping each other, you're going to have an infinite number of solutions. So there are an infinite number of solutions. Okay, so if you try to graph this line, here y-intercept is 2, slope is negative 1 over 2, so down 1 over 2, down 1 over 2, down 1 over 2, and so on. And so you could see there's no other line to draw. It's the same line for both equations. Oh, I'll fix this line a little bit. Okay, and there you go. All right, so we can't draw any other line. There's another point of intersection. It's the same line all the way through, so you have an infinite number of solutions. Every point on that line is a solution to the linear system. Okay, so equivalent linear equations, they have the same graph. And can be written by multiplying the equation by any real number. Okay, what this essentially says is that if you took this equation, y equals 2 minus 1 half x, and multiplied by any number, so you can multiply it by 2. If you multiply it by 2, you get the same thing as equation 1. If I multiply the equation by 4, I get the same thing as equation 2. So no matter what number I multiply it, if I multiply it by any number, the entire equation, I'm going to get the same thing. It's the same line. It's the same graph. So that's what that means. Okay, so let's solve another one. So solve each linear system. What do you notice? If you look between the system between A and B, you might carefully, take a moment and look at it. Pause the video if you have to, but look at it. They would look the same. They are equivalent as well. So let's look at that. Well, let's look at y. So here's equation 1, here's equation 2. Let's make this equation 3 and this one equation 4. So if we look at equation 1, and let's isolate the y on the left side. So negative 6y equals, and let's put the 3x, subtract 3x from both sides. So minus 3x on the right side plus, don't forget about the 15. So there's equation 1. What if I take equation 1 and I divide by negative 6? So everything divided by negative 6. Well, here's what I would get. Y equals, on the left, and on the right I'd get 1/2 x, because two negatives make a positive, and negative 5 over 2 if I reduce that fraction. 15 over negative 6 becomes negative 5 over 2. Okay, so that's what it is. All right, so let's look at equation 2. There's nothing much I can do to equation 2 except subtract x from both sides. So y equals negative x plus 3. Okay, good so far? I hope so. Let's look at equation number 3 now. I take equation number 3. Let's isolate for y here. So negative 2y on the left. If you subtract x on both sides, you get minus x, and you have your plus 5. Okay. And let's look at dividing the entire equation by negative 2. Like so. And if you simplify, well, on the left side I get y, and then on the right side I have negative over negative is positive, so positive half of x, and minus 5 over 2. Whoa, look at that. They are the same. It's the same. Equation 1 and equation 3 are exactly the same. Okay. What about equation number 4? Well, equation number 4, isolate the y, so 2y equals, subtract 2x from both sides, so negative 2x plus 6. If I divide this equation by 2, well, it turns out that I also get y equals negative x plus 3. It's the same thing as equation number 2. Okay, so we have equivalent linear systems. Well, we can still solve each system. So system A and system B. Let's plot. There are two distinct equations here, two lines that I can plot. So with the first one here, I have negative x plus, 1 over 2x minus 5 over 2. So 1 over 2x. So 5 over 2 is the same thing as 2.5. So negative 2.5 is right about here. Okay. And the slope is rise over run. So rise 1 over run 2. So right about there. Rise of 1 over 2 right there. So I can zoom in so you can clearly see that. So rise of 1 means I'm going to go up 1, and a run of 2, up 1, and a run of 2, up 1, and a run of 2. Okay, that's the best you can do, really. There's not much more you could do. Okay, and so the other equation was negative x plus 3, so I need to start at 3. And the slope is minus 1, so down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. So somewhere along the way, the two lines are going to intersect, but that point isn't quite clear. Somewhere here it's going to intersect, but it doesn't fall in a very easy, nice point to read. Okay, so what I'm going to say here is that we have two systems, A and B. So if these are equivalent systems, what does that mean? Well, I'm going to say, well, therefore, if they are equivalent systems, then they will have the same solution or same point of intersection. Okay, but it's tough to read. So it's tough to read from the graph. So it's tough to read from the graph. Then we're going to need to do something in terms of algebra. So we need algebra. Algebra will help us find that solution more accurately. And this is not the focus of the lesson. This lesson is about graphing by hand and solving by graphing by hand. So what we're going to do is save this algebraic methods or there's more than one for the next video. Okay, so equivalent linear systems, we'll say here they have the same solution and can have equivalent linear equations for one or both equations. Okay, so there is some practice for you to try, graphing by hand and solving by finding the point of intersection of each linear system. And that ends this video. And I also suggest, as you graph them, and you find your point of intersection, use Desmos to check your answer. Okay, but it's very important that you know how to graph this by hand. All right.